Solve for x, and x is an element of the real number set. 8 to the power of 1 minus 2x is equal to the square root of 1 over 32 to the power of x. So what we want to do here is make the 8 and the 32 into the same base. And if we have each side of the equal sign having the same base, we can cancel out the bases and let the left-hand side equal the right-hand side. So the indices on the left equal the indices on the right, and then we can just solve for x. So we're going to make 8 and 32 to be a base of 2, and then we're going to work through our question until we have 2 to the power of something is equal to 2 to the power of something. So we can cancel out the 2's, and then let the left-hand side equal the right-hand side and solve for x. So let's start off with the 8, and we're going to change that to 2 to the power of 3 with brackets around it. It's very, very important that we put the brackets around it. So 8 can be changed to 2 to the power of 3. So 8 with a base of 2 is going to be 2 to the power of 3. We put brackets around it, and that is still to the power of 1 minus 2x. So I've just brought the 1 minus 2x down here and put it at the top of the bracket. Then the next thing I'm going to do is just get rid of the square root and the 1 over, because I don't want to have a fraction on my right hand side. So I'm going to use two of my laws of indices. These are a couple of my laws of indices over here on the right. I'm going to use two of my laws of indices to rewrite the right hand side of my equation, to get rid of the root and to get rid of the 1 over. So firstly, I can use law 5, and I'm going to work backwards with law 5, so I'm going to go in reverse. So law 5 says that a to the power minus p is equal to 1 over a to the power of p. So if I work backwards with that, 1 over 32 to the power of x is going to be equal to 32 to the power of minus x. So we get rid of the 1 over, and we change the positive x to a minus x. So we're using law 5, but we're working backwards. The next thing I'm going to do is get rid of the root part, and I'm going to use law 6 to do this. And again, I'm going to work in reverse. Law 6 says that a to the power of 1 over q is equal to the cubed root of a. So I'm going to work backwards. So I'm going to say the square root of 1 over 32 to the power of x is going to be 32 to the power of minus x to the power of a half. So that root becomes to the power of a half, and that 1 over 32 to the power of positive x becomes 32 to the power of minus x. Now I could have changed the 32 to a base of 2 in that step as well, but I just didn't want to have 3 steps in the one step. So next we're going to work out 2 to the power of 3 raised to the power of 1 minus 2x. And we're going to use law 3 to help us with this. Law 3 says if we are raising a power to a higher power, we multiply the powers. So we're raising a power, 3, to a higher power, 1 minus 2x. So we're going to multiply those powers. So I'm going to multiply the 3 by the 1 to give me 3. And also the 3 by the 2x minus 2x to give me minus 6x. So 2 to the power of 3 raised to the power of 1 minus 2x. I'm going to multiply the powers because of law 3. 3 multiplied by 1 is 3. 3 multiplied by minus 2x is minus 6x. Now in this step I'm changing the 32 to a base of 2 with brackets around it, always brackets around it, and that is going to become 2 to the power of 5. So now I have 2 to the power of 5 raised to the power of minus x raised to the power of a half. So on the left hand side I still just have 2 to the power of 3 minus 6x. Nothing actually changes on the left hand side. And on the right hand side I'm going to multiply 5 by the minus x because I'm raising a power to a higher power. So I multiply the powers, again using law 3, and 5 multiplied by minus x gives me minus 5x. And this is still all raised to the power of a half. So again, I have 2 to the power of 3 minus 6x on the left-hand side. Haven't done anything with that. And then on the right-hand side, I have 2 to the power of minus 5x raised to the power of a half. And again, I'm going to use law number 3. Raising a power to a higher power, I multiply the powers. So I'm going to multiply minus 5x by a half. And this is going to give me minus 5x over 2. So I'm going to do this step out over here on the right hand side because it's involving fractions. So minus 5x I can actually put over 1 because I can put anything over 1, any whole number over 1 or whole term over 1. And I'm multiplying that by a half. So minus 5x becomes minus 5x over 1. And a half just stays as a half. And I'm multiplying fractions, so I do top by top, bottom by bottom. And minus 5x times 1 is minus 5x. And 1 times 2 is 2. So that's where the minus 5x over 2 comes from. Okay, so now I can see on my left-hand side I have 2 to the power of 3 minus 6x. And on the right-hand side, I have 2 to the power of minus 5x over 2. And I notice that I have the bases now matching, which means I can cancel out my bases. And what I'm going to do is bring down the indices on the left-hand side, 3 minus 6x. And I'm going to bring down the indices on the right-hand side, minus 5x over 2, and put an equal sign in between. So what I've done here is just cancelled out the 2's on either side. So now I just have a linear equation that I'm going to solve for x. So first step I'm going to do is I'm going to try and break up this fraction. I have minus 5x divided by 2. So I'm going to multiply by 2 on both sides so that I get rid of the fraction part. So what I do to the right, I do to the left. What I do to the left, I do to the right. If I'm multiplying by 2 on the right-hand side, I must do that on the left-hand side. 3 multiplied by 2 gives me 6. And minus 6x multiplied by 2 gives me minus 12x. And then I'm just left with minus 5x on the right-hand side because I got rid of my denominator. Now I have a linear equation where I have x's on both sides. So I'm going to bring all the x's together. So I'm going to bring this minus 12x over the equal sign, and it becomes plus 12x. And plus 12x minus 5x is going to give me 7x. So I'm going to still have the 6 on the left-hand side equals to 7x. And then to get the x on its own, I need to get rid of this 7. So I need to divide both sides by 7. So I'm going to end up with x is equal to 6 over 7.